So let us discuss today about the term in thermodynamics which is called entropy. Now entropy, when we discuss entropy, there are two aspects of entropy. One is the mathematical aspect, and another is the physical aspect. Mathematical aspect and a physical aspect. So we will first see the mathematical aspect. In fact, the entropy was discovered from the mathematical aspect only. It was discovered by Clausius. Clausius has discovered a mathematical term, and that mathematical term he has called as entropy. Now, how does mathematical terms come to the picture? It actually comes from the Carnot engine. So, if we take the Carnot engine, let us see the Carnot engine. Carnot engine or আমি কি দেখা পাইছিল যে wherever it takes some heat, let it be QH, and it gives QL to the sink. Source of QH heat level, sink of QL heat level. And we have also seen the expression for efficiency, which was like this: QL by QH. And in terms of temperature, it is T2 by T1. Now, if we equate these two, then we will get QL by QH equal to, let it be, মই to L লিখি আছো, H লিখি আছো, so let it be L PL by PH. So PL by PH. Now you divide, that means if you rearrange it, then you will get QH by PH equal to QL by PL. And this gives rise to QH by PH minus QL by PL equal to 0. So during one cycle, if you see, during one cycle, QH minus QL is not equal to 0. In fact, it is equal to how much? It is equal to W. So Carnot engine আমি দেখা পাইছো যে QH minus QL, that is in one complete cycle তুমি যদি চোৱা, in one complete cycle QH minus QL, it is equal to the work done, that means it is not equal to 0. That means while you are starting from point A and you are again coming back to point A. So during this whole process, the change of heat, তুমি source পৰা heat এইটো গেছটোৱে heat লৈছে, heat এৰি দিছে, এইবিলাক আকৌ আহিছোঁ আমি ইয়াত লৈকে. So during that whole process, the difference of heat taken and the heat given to the sink is equal to W. That means that heat is depending on the path you are taking. It depending on the path. So বেলেগ পাথৰ মাজেৰে গৈছে, so ultimately it is not equal to 0 because মই ইয়াৰ পৰা ষ্টাৰ্ট কৰি পেলাই আকৌ ইয়ালৈকে আহিলে মোৰ এইটো যদি 0 হ'লহেঁতেন, if it is 0 then I should have tell that it is not depending on the path, it is depending on the state, because এইটো ষ্টেটত যিটো হিট আছিলে ইয়াৰ পৰা গৈ আকৌ যদি ইয়ালৈকে আহোঁ, I should have the same heat if heat is your state function. যদি হিটটো state function হ'লহেঁতেন, মই 8 পৰা যিমান হিট লৈছিলোঁ, 8 থাকোঁতে যিমান হিট লৈছিলোঁ, আকৌ 8 গৈ পাওঁতে I should have same amount of heat. That means ইয়াত যিটো এনাৰ্জি থাকিলেহেঁতেন আছিলে, মই যদি এনেকৈ গৈ আকৌ যদি ইয়ালৈকে আহোঁ, যদি হিটটো ষ্টেট ফাংচন হয় তেতিয়াহ'লে I should have same amount of heat, কিন্তু মোৰ সেইটো হোৱা নাই. QH minus QL is not equal to 0. QH is not equal to QL. But Clausius has noticed that if I divide this QH by TH and this QL by TL, QL to TL divide karo and QH to TH divide karo, then it becomes equal to 0. From here I can see this. So here I will dekha pao QH by TH is equal to QL by TL. But QH minus QL is not equal to 0. So Hitudra, what Clausius has concluded, Clausius concluded that this QH by TH has the property, this QH by TH has a property of a state function, because মই ইয়াৰ পৰা ষ্টাৰ্ট কৰি পেলাই আকৌ যদি যাওঁ during this one cycle, QH by TH is equal to QL by TL. So that property does not change. That property means that parameter does not change. QH is not equal to QL. That means heat is not your state function. কাৰণ মই ষ্টাৰ্টিঙত যিমান হিট লৈছিলোঁ, আকৌ যদি ঘূৰি আহি পেলাই আকৌ যদি ষ্টাৰ্টিং পইণ্টত পাওঁ, চেম এমাউণ্ট অফ হিট মই নাপাওঁ. বাট যদি মই QH-ত যদি মই TH ডিভাইড কৰোঁ আৰু QL-ত যদি QL ডিভাইড কৰোঁ, তেতিয়াহ'লে কি হয়, they are equal. That means this term QH by TH or QL by TL, this term is a new parameter and it is a state function. Why it is a state function? Because starting of G2 by ratio, whatever ratio I am getting in the starting, QH by TH, this is equal to QL by TL. Ako jodi am ghori pelai eloke jam, I get the same ratio. The ratio doesn't change. That means this ratio does not depend on the path you are taking. It depends on what? It depends on the state. Yet jitu asile ako ahi pe tumi jodi taat joa, you get the same. So it depends only on the state. Air plus start korte more QH by TH asile, ako ghuri poke ako jodi L ke aho, again I am getting QH by TH. Kintu air plus start korte more QH asile, kintu ako jodi ghuri ahe, it will not be QH. Clear ase kotha to? So heat is not a state function, but তাত যদি মই temperature divide কৰি দিওঁ, then it becomes a state function. And that gives us Clausius to introduce a new parameter in thermodynamics. And what parameter? It is a heat divided by the temperature. What kind of temperature? যদি মই source heat to লৈ আছো, source temperature divide কৰিব লাগিব. If I am taking the sink heat যদি মই লৈ আছো, then I have to divide it by the sink temperature. So that ratio Clausius found to be a state function, and he named this ratio, that means heat taken or given divided by the temperature. That তোমার heat taken, heat given দুইটা হ'ব পাৰে, heat ল'ব পাৰে, heat দিব পাৰে, but you have to divide it by the temperature. যদি তুমি divide কৰা তেতিয়াহ'লে then that term is, this is called as an entropy. So Clausius named this parameter as a change, as a entropy. What parameter? Not only the heat divided by the temperature. So very simple term, just heat তুমি লবা, then we divide by temperature, then its property changes. অকল হিটটোৰ লগত যিটো property আছিলে তাক যদি temperature divide কৰি দিয়া, then your property will change. It becomes a state function. So what we can say that this is a new parameter. It is not internal energy, it is not heat, it is not pressure, not volume. এইবিলাক নহয়. So এইটো যদি নহয় তাৰমানে it is a new parameter. আর এই প্যারামিটারটো কি হয়? This is a state function. So Clausius tell that এই যোনটো প্যারামিটার আছে এই প্যারামিটারটো হল কি যে it is a state function and it is called as an entropy. And entropy is a Greek word. আর entropy meaning to is a transformation of heat. So that means whenever you have a transformation of heat, that means তুমি হিটটো লৈছা বা হিটটো এৰি দিছা, that divide by the temperature তুমি যদি কৰি দিয়া, then he called it as a new parameter for entropy. So like that the entropy come into the picture in thermodynamics. So Clausius is the main person who introduced a new term called entropy to thermodynamic community. But it is only mathematical term. Clausius could not explain what this mathematical term actually means. It is কি বুঝায় এটো Clausius ক'ব পৰা নাছিল। Okay, মানে তাৰ মিনিংটো নাজানে, তাৰমানে ই জাস্ট নতুন এটা mathematical term এটা ইভলভ হ'ল, a new mathematical term has been evolved, but what is the meaning of that nobody knows. So this is the starting point, and from this Clausius has given a theorem. He has formulated a theorem that is called Clausius theorem. Clausius theorem. So Clausius theorem কি কয় যে if you take a reversible process, আর সেই reversible processত তুমি যদি গোটেই এটা কমপ্লিট সাইকেল এটা যদি তুমি আহা, ফর এক্সাম্পল তুমি কানৰ ইঞ্জিনটো লোৱা, কানৰ ইঞ্জিনত তুমি এৰ পৰা ষ্টাৰ্ট কৰি বি চি ডি আকৌ এ লৈকে যদি আহা, ডিউৰিং দিছ ওৱান কমপ্লিট চাইকেল the small amount of heat taken divided by the T is the term, because this is entropy, no? Entropy is what? The heat divided by the temperature. So ইয়াত মই কি কৰিম? I will take small amount dq. That means I will take like this. Small amount of heat dq, small portion of the law. ইয়াতে মই গোটেইখিনি during this whole process A to B I am taking qh. কিন্তু গোটেইখিনি process নলৈ পেলাই মই যদি এটা small portion লওঁ, a small portion amount of heat taken will be how much? dq. So that dq by t, আর তাক যদি মই ইন্টিগ্রেট কৰি দিওঁ তেতিয়াহ'লে মই কি যে পাই যাম, গোটেইখিনি পাই যাম। So what he did, he take a small portion dq divided by the temperature and for the whole reversible cycle. For the whole reversible cycle. And what he found it, this is a whole reversible cycle, or zero. That means this is nothing but the integration of dq by t. So dq by t যদি integrate করা, then that will be equal to 0. So for a reversible process, if you do the integration of this dq by t, then it will be equal to 0. Now for irreversible process, this is for reversible process. The irreversible process er karone ki hobo? Now it can be shown that if it is an irreversible process, that means you are going like this. তুমি এর পৰা বি লৈকে গৈ আছা. Let it be a reversible process. তুমি এর পৰা বি লৈ গৈ আছা, and you are coming back from B to A through a irreversible path. B পৰা A লৈকে তুমি আহি আছা through a irreversible path. গতিকে complete cycle to যদি মই লওঁ, if I take the complete cycle from A to B and again from B to A, what kind of process it is? It is a irreversible process. এটা reversible আছে, আনটো কি আছে? Irreversible আছে. গতিকে whole cycle to যদি মই চাওঁ, this irreversible. And he had shown, Clausius has shown that for an irreversible process or irreversible path, this dq by t is less than 0. It is less than 0. So ultimately মই কি পাম? দুইটা যদি মই চাওঁ, that means if I consider a reversible process and irreversible process together, দুইটা যদি একেলগে চাওঁ, then I can write it like this: reversible and irreversible process দুইটা যদি একেলগে চাওঁ, then I can write dq by t is less than equal to 0, and this is what called Clausius theorem, or it is also called Clausius inequality. Inequality আছে, এখানে equal নহয়, inequality less than 0. It is also called Clausius inequality. হৈছে, this is Clausius theorem. আৰু এই Clausius theorem পৰা I can, এই Clausius theorem যোনটো আছে, Clausius theorem টো ক'ৰ পৰা আহিছে? ultimately this coming from this fact. Okay, ইয়াৰ পৰা আছে. গতিকে মই কি ক'ম এতিয়া? মই এন্ট্ৰপিটো কেনেকৈ ডিফাইন কৰিম? এন্ট্ৰপিটো মই এনেকৈ ক'ম যে if I go from A to B, মই যদি A ৰ পৰা B লৈকে যাওঁ, if I go from A to B, there is a change of some parameter. এটা parameter থাকিব, যেনেকৈ মোৰ A ৰ পৰা যদি B লৈকে যাওঁ, if I look at the internal energy, ইয়াত যদি internal energy U1 থাকে, ইয়াত যদি energy U2 থাকে, so change in internal energy কিমান হ'ব? It will be equal to U2 minus U1. Okay. Similar to that, entropy is also a state function. গতিকে তুমি যেতিয়া A ৰ পৰা B লৈকে যাবা, তেতিয়াহ'লে তোমাৰ কি হ'ব? There will be change of something. And what is that something? That something is called the entropy. That means whenever you are going from A to B, like your internal energy, the entropy will also change. Entropy to কি হ'ব? Change হ'ব. কিন্তু যদি reversible process হয়, if it is a reversible process, তেতিয়াহ'লে তোমাৰ কি হ'ব? During the whole cycle, it will be equal to 0. Just like your internal energy. তুমি এর পৰা B লৈকে গৈছা, internal energy change হ'ব, আকৌ B ৰ পৰা A লৈকে আহা, কি হ'ব? একে থাকিব. It is a state function. Internal energy is a state function. Similar to that, your entropy will be also be a state function. So during one cycle, this dq by t ultimately will be equal to 0. But if you go from A to B, that means if you define it like this, যে মই A ৰ পৰা B লৈ গৈ আছো, then I will have some value, and this is called the change in entropy. This is called change in entropy. So whenever you go from a state A to state B, there will be a change of entropy. So if you go from A to B, but if you again coming back from B to A through a reversible process, then total change will be how much? 0. But if you go from A to B, there will be a change in entropy. What is entropy? Entropy is nothing but QH divided by T. That means তুমি A পৰা B লৈকে যাওঁতে যদি তুমি Q amount of heat লৈছা and your temperature is T, তেতিয়াহ'লে QH by T তুমি divide কৰি দিয়া, whatever you are getting, that is nothing but your change in entropy. But we don't know what does it means. Internal energy change হোৱা মানে আমি জানো যে internal energy change হৈছে বা কমিছে বা বাঢ়িছে, we can feel. But entropy change হোৱা মানে কি change হৈ আছে, nobody knows. We don't know what actually changes. Entropy change মানে কি change হৈ আছে, we don't know. But mathematically we know যে তুমি যদি amount of heat যেটো লৈ আছে তাক যদি temperature divide কৰা, that is the amount that is changing. What is changing? The ratio is changing. QH by T. So that means there is something, কিবা এটা বস্তু আছে, because QH by Q by T is a state function, so it must be something, and Clausius has pointed out that this is entropy. So we can now say that if I go from A to B, entropy will change. কিন্তু মই এইটো কথা নাজানো যে এর পৰা B লৈ গ'লে entropy change হৈ থকা মানে actually কি change হৈ আছে, what is changing, I don't know. Clear? So এইখিনি আমাৰ এতিয়া clear হ'ব লাগে যে there is a parameter called entropy, and which changes if you go from one state to the another state. But I don't know change of entropy means what. Only mathematically I know that change of entropy means তুমি যিমানখিনি হিট লৈছা সেই টেম্পারেচার ডিভাইড কৰি দিয়া, that means it will change. কিন্তু সেইটো চেঞ্জ হোৱা মানে ফিজিক্যালি কি হৈ আছে, ক'ত কি ঘটনা ঘটি আছে, I don't know. So mathematically what I can do, I can find out the change in entropy. So change in entropy কিমান হ'ব, if I go from A to B, change in entropy will be equal to integration from A to B that dq by T. But if you take the full cycle, গোটেই cycleটো যদি লোৱা, then for reversible it will be equal to 0, and for irreversible it will be less than 0. This term is called the change in entropy. So this term is independent of the path. তুমি এর পৰা বি লৈ গ'লেও এইটো ভ্যালু থাকিব, আকৌ বিৰ পৰা এ লৈ গ'লেও কি হ'ব, এইটো ভ্যালু পাব। তাৰমানে এৰ পৰা বি লৈ গ'লে যিমানখিনি চেঞ্জ হ'ব dq by T, বিৰ পৰা এ লৈ আহিলেও dq by T, the change will be same. So right now what we can say that there is a parameter that we got by dividing the heat by the temperature, and that I can call as a entropy, and which changes if I go from one state to another state, and it doesn't change if I complete one cycle. That means it is not a path dependent parameter, it is a state function or state parameter. So that much we know. Okay, so এইখিনি জনাৰ পিছত now we are eligible, because we don't know what is entropy, but we are now eligible to find out the change in entropy. এটা আমি সিস্টেম এটা লম, সিস্টেম এটাত আমি এটা স্টেটৰ পৰা আনটো স্টেটলৈকে যাম, আৰু সেইটো যাওঁৰ সময়ত আমি কি কৰিব পাৰোঁ, we can now eligible to calculate the change in entropy. আমি চেঞ্জ ইন এন্ট্ৰপিটো আমি উলিয়াব পাৰোঁ। আৰু এটা কথা মন কৰিবা, the change in entropy যেতিয়া তুমি উলিয়াবা, then each and every moment your system must be in equilibrium. গতিকে মই যোনটো চেঞ্জ ইন এন্ট্ৰপি পাম, চেঞ্জ ইন এন্ট্ৰপি, তাক মই ds এৰে বুজাম, that means entropy is denoted by S. So ds will be equal to dq by T, and this must always be in T. So you can only calculate the change in entropy whenever you are in a equilibrium position. So that means you must be in a reversible position or reversible process. এটা reversible process তুমি থাকিব লাগিব. Only in reversible process only I can calculate the change in entropy. But later we will see that this entropy we can also calculate in case of irreversible process. Etu kene korbo lage ami sam mathematically. But right now this is our definition. So ds তোমাক যদি কয় যে তুমি এটা স্টেটৰ পৰা আনটো স্টেটলৈ গৈ আছা, you find out the change in entropy. তুমি কি কৰিবা? তুমি কৰিবা যে এইটো স্টেটৰ পৰা আনটো স্টেটলৈ যাওঁতে কিমান এমাউন্ট অফ হিট হৈছে divide by the that temperature. If you কৰি দিয়া, you can get the change in entropy. So আমি Clausius inequality পালো. Clausius inequality তো আমরা কি কৈছে যে Clausius inequality or Clausius theorem says that for reversible process this integration closed integral dq by t is equal to 0 and for irreversible less than 0. So this is my Clausius theorem. এতিয়া ইয়াৰ পৰা আমি আকৌ দেখাব পাৰো, we can show that for an isolated system the SF is greater than SI. SF greater than SF. What is SF? SF is the final entropy. What is SI? SI is the initial entropy. Initial state of the entropy is SI. Final state of the entropy is SF. And for an isolated system, SF is always greater than SF. That means SF minus SI is greater than 0. That means del S is greater than 0. So change of entropy always greater than 0 if you go from initial state to the final state for a isolated system. And from here I can define the second law of thermodynamics again. Second law of thermodynamics. So I can now define second law of thermodynamics in terms of entropy, and it says that change in entropy of the universe always greater or equal to 0. Universal karone amar change of entropy to ki hoy always greater or equal to 0. It cannot be less than 0. That means whenever you go from one state to another state, entropy always increases, or at least it will be equal to 0. So it cannot be less than 0. This is called the second law of thermodynamics. So second law of thermodynamics can be defined in terms of entropy, which says that the change in entropy is always greater or equal to 0. So if a spontaneous process happens, then your entropy always increases. And heat engine is a spontaneous process. Spontaneous process means heat will go from the hot end to the cold end. This is a spontaneous process. Heat cannot go from cold end to the hot end. This is not a spontaneous process. তুমি যদি নিব লগা হয় heat to কোল্ডৰ পৰা হটলৈকে বাহিৰৰ পৰা কি দিব লাগিব এনাৰ্জি দিব লাগিব বাট ফ্ৰম হটৰ পৰা কোল্ডলৈকে যদি হিটটো যাব লগা হয় নো এনাৰ্জি ইজ ইকুৱেল টু স্পন্টেনিয়াছ প্ৰসেছ সো স্পন্টেনিয়াছ প্ৰসেছ যদি হয় তাৰ কাৰণে আমাৰ কি হয় এন্ট্ৰপি অলৱেজ ইনক্ৰিজেস so all these things we will see but right now we will know that the second law of thermodynamics can be defined in terms of entropy which is the change in entropy of the universe is always greater or equal to at least minimum equal to 0 however minimum negative however it cannot be less than 0 the universal change in entropy cannot be less than 0 so these all we will see mathematically after that physical significance of sum so right now you just know that there is a term called entropy which we got dividing the heat by the temperature and he juntu term is a state function আৰু সেইটো তুমি যদি এটা ষ্টেটৰ পৰা আনটো ষ্টেটলৈকে যোৱা ইট অলৱেজ ইনক্ৰিজেছ এণ্ড ফৰ এ ৰিভাৰ্চিবল প্ৰচেছ ক্ল'জ ৰিভাৰ্চিবল প্ৰচেছ ইট উইল বি ইকুৱেল টু চেঞ্জ উইল বি ইকুৱেল টু 0 তুমি য'ৰ পৰা ষ্টাৰ্ট কৰিবা আকৌ তাতে আহিবা ষ্টেপ ফাৰ্ষ্ট so now let us calculate some the change in entropy because আমি এতিয়া mathematically কথাটো গম পালো we know the entropy from the mathematical aspect গতিকে mathematical aspect to যেহেতু আমি গম পাইছো গতিকে we should now do some calculation to calculate the change in entropy আমি change in entropy to আমি উলিয়াম for some system let us take a reversible system first let me consider a reversible system the reversible system to কেনেকুৱা হ'ব because আমি তো জানো যে we know that there is no reversible process but still we can consider that certain processes to be as reversible so let me consider a reversible process where I am putting a cylinder over a reservoir that a reservoir with a lusuma I am taking a reservoir with a reservoir and I am putting a cylinder I am putting this cylinder on this reservoir tar heat to tomar Q ase and temperature is T I am taking a gas so if I take a gas heat reservoir at temperature T and if I allow this system allow this gas to expand suppose now the temperature of the gas is T moya gas to moya to disu reservoir to disu and the gas is attaining the temperature T it will be hoy tar pisot once the gas is attaining the temperature of the reservoir now I am allowing the gas to expand the gas to jodi moi allow koru if the gas expands then the gas is my system yet more this will be system and this will be my surrounding but because even though all are adiabatic was so nothing can go outside so system or pra yaloke ahibo pare so there is a connection between this and this so I will call it as a system and I can call it this as a surrounding it is more gas to expand hobo diu then the system will take dq amount of heat the system will take dq amount of heat kiman temperature lobo at what temperature at temperature kiman T because the reservoir temperature to T ase aru system to temperature T ase so now I am allowing the system to expand and the system will take how much heat dq amount of heat lobo lobo from the so here tomar system is taking dq amount of heat from the surrounding kiman temperature loi ase at temperature T so change in entropy of the system kiman hobo and change in entropy of the surrounding kiman hobo what will be the change in entropy of the system or entropy to kiman change hobo entropy ami keneke define koru entropy define koru je kiman heat loi ase ba kiman heat eri dise at one particular temperature so system to kiman heat loi ase how much it is taking dq amount of heat loi ase kiman temperature loi ase T temperature loi ase so your entropy change kiman hobo plus dq by T positive hobo no it loi ase heat is taking so I will put it like this dq by T dq by T this is a reversible process okay this is a reversible process this is a reversible process plus dq by t. The change in entropy of the system, that means my system to eta state asile etu state or eta beleg eta state lo gusi gol and during that kiman heat loi ase dq amount of heat loi ase ar kiman temperature loi ase t temperature loi ase. So change in entropy will be dq by t. Same time on at the same time, what is the amount of heat that is given by the surrounding, that is given by the reservoir? dq amount of heat যদি সিস্টেমে লৈ আছে তেতিয়া হলে রিজার্ভারে এই amount কি হ'ব লাগিব give লাগিব, it has to release that amount of energy. So what will be the change in entropy of the surrounding, that means reservoir, minus dq by t, because now heat is released, minus dq by t. Now you see for this your system, the change in entropy is positive, and for the surrounding change in entropy is same value, magnitude is same but it is negative. It is more change in entropy of the universe jodi sound, universe means what? The system plus surrounding. So change in entropy of the universe will be equal to how much? 0. So this is a reversible process. So reversible process organic Q1, the change in entropy will be equal to 0. Okay. But for the surrounding, you see, for the surrounding, that means for the reservoir, it may be negative. It may be negative, means yet negative hoye ase, it is negative, and the system organic Q is positive hoye ase. Okay. So system and surrounding, there may be your change in entropy may be positive as well as negative, but for the universe it cannot be negative, which is our second law says. So second law to koi? Second law to call that the change in entropy of the universe cannot be negative. It always has to be either 0 or greater than 0. So if I am taking a reversible process, how much I am getting? 0. So let me take a irreversible process. The irreversible process more sum. That is more keep on more sum. I'll take an irreversible process. Okay. So you see, apo more tomorrow process. Now we are calculating change in entropy. আমি ধৰি লৈছো যে এটা ষ্টেটৰ পৰা আনটো ষ্টেটলৈকে যাওঁতে কিবা এটা বস্তু চেঞ্জ হয় আৰু কিবা এটাটোক আমি কি বুলি কৈ আছো এন্ট্ৰপি বুলি কৈ আছো আৰু এন্ট্ৰপিটো ম্যাথমেটিক্যালি কেনেকৈ ডিফাইন কৰি আছো the amount of heat taken by particular temperature or amount of heat given by the temperature, but we don't know what is this entropy. Entropy change হৈ আছে মানে কি actually change হৈ আছে, what is actually changing, we don't know. We only know that dq by t is changing, that only we know. So it is irreversible process. If you take an irreversible process, let me consider that when a mass of the substance long object of mass kg and specific heat c, you take an object of mass m kg, specific heat c, joule per kg per Kelvin, specific heat, and temperature is changing from Ti to Tf. It is an irreversible process. Okay, এটা অবজেক্ট যদি মই লৈছো তাক যদি মই হিট আপ কৰিলে কি হ'ব, তাৰ temperature will change from Ti to Tf. Now that is irreversible process. আমি তাক irreversible বুলি easily ধৰিব পাৰো. It may be reversible, but irreversible হোৱাৰ possibility বেছি. তুমি এটা যদি বল এটা লোৱা, আইৰন বল এটা লোৱা, হিট ইট আপ, তাক তুমি টেম্পাৰেচাৰটো তুমি দিলা, হিট কৰাৰ লগে লগে টেম্পাৰেচাৰ ইজ ৰাইজিং ফ্ৰম Ti to Tf. So it is very difficult to again come back from Tf to Tf without affecting the surrounding. So it is an irreversible process. So irreversible process যদি হয়, ইয়াত মই যদি চেঞ্জ ইন এন্ট্ৰপিটো ওলাব লগা হয়, if I want to find out change in entropy, change in entropy to আকৌ কি কেনেকৈ ডিফাইন কৰো, amount of heat taken divided by the temperature. Period তোমার টেম্পারেচারটো কি হৈ আছে, চেঞ্জ হৈ আছে, টেম্পারেচার is changing from Ti to TF. So now how you will use this formula? dq by t, because dq by t মানে কি temperature, এটা temperature লাগিব তো, but now how many temperatures are? Lots of temperature. T er পৰা গৈ TF পাম. So what I should do now? মই কেনেকৈ calculate কৰিম? Can you give me any idea how I can calculate the change in entropy while it will go from Ti to TF? Okay, integrate করলে তো তুমি পাবা, কিন্তু মই টাইম টেম্পারেচাৰ যোনটো আছে, টেম্পারেচাৰটো কি হৈছে, চেঞ্জ হৈ আছে ন, গতিকে এটা পাৰ্টিকুলাৰ মোমেণ্টত যদি মই কেলকুলেট কৰিব লগা হয় তেতিয়াহ'লে মই কি লাগিব, ডি কিউ বাই টি লাগিব। Okay, that means I have to take a very small steps. I have to go through a very small steps. Okay, I'll একদম small step যাম মই, য'ত মোৰ টেম্পাৰেচাৰটো কি থাকিব, একে থকা বুলি ধৰি ল'ম। So I shall take a very small step here, that will be dq by t at that particular temperature. সেইটো যদি হয় তেতিয়াহ'লে যদি মই ইন্টিগ্ৰেট কৰোঁ, if I integrate it from Ti to Tf, then I will get the total change in entropy. Small change in entropy going to ultimately what integration যদি কৰোঁ, then I will get the total change in entropy. কিমানৰ পৰা কিমানলৈকে? Ti to Tf. Ti to Tf. আৰু এৰিটা small stepত মই কৰি যাম আৰু মই সেইটো এড কৰি কৰিম। So initially suppose তোমাৰ Ti লৈছোঁ, next আউটত মই ল'ম Ti dash, next আকৌ ল'ম Ti double dash, next আকৌ ল'ম Ti triple dash, and গৈ I will reach what? I will reach Tf. So এনেকৈ যদি T actually reach কৰোঁ তেতিয়াহ'লে মই আল্টিমেটলি গোটেই প্ৰচেছটোক মই কেনেকৈ বুজাব পাৰোঁ, I can denote it by like this. So I can denote it like this, Ti to Tf dq by t, where t changing from Ti to Tf. Okay, so whenever there is a change in temperature, I can find out the change in entropy by integrating it from Ti to Tf. আৰু সেইটো মই কেনেকৈ ৰিয়েলাইজ কৰি আছোঁ, I am realizing it by considering very small steps. হৈছে? এতিয়া ঘটনাটো হ'ল, what is the dq, কিমান এমাউণ্ট অফ হিট লৈ আছে while going from Ti to Tf, কিমান এমাউণ্ট অফ হিট লৈ আছে, what is the amount of heat the object is taking while going from Ti to Tf? mc Tf minus Ti. This is the total amount of heat that is taking by the object while going from Ti to Tf. Again মই কি কৰিম, small steps ল'ম। So small step যদি মই ল'ম, then I can write mc dt. I can write what? mc dt. So this dq I can replace by what? mc dt divided by t. mc dt divided by t. এতিয়া ইয়াত যদি ইন্টিগ্ৰেট কৰা কি পাবা, ln of t. Okay, the integration will be how much? ln of t, because mc these are constant. This will give me del s will be equal to mc ln of Tf by Ti. mc ln of Tf by Ti. So this is the change in entropy while going from the temperature Ti to Tf. Okay? So how I am calculating it? I am taking the integration. So this is one process of calculating the entropy. আগতটোত মই কেনেকৈ কৰিছিলোঁ, আগতটোত মই ইন্টিগ্ৰেশ্যনৰ দৰকাৰ নাছিলে, জাষ্ট কিমান হিট লৈছে, কিমান টেম্পাৰেচাৰত লৈছে, that ratio is giving me the change in entropy. কিন্তু ইয়াত মোৰ যেহেতু টেম্পাৰেচাৰ চেঞ্জ হৈ আছে, so I have to do the integration. Clear হৈছে? So this is the way of calculating the entropy. আমি আৰু চাম এক্সাম্পল। কিন্তু ঘটনাটো হৈছে কি, এতিয়া আমি কিমান পালোঁ, এইটো দিছে যে ইৰিভাৰ্চিবল প্ৰচেছ, আৰু এই ইৰিভাৰ্চিবল প্ৰচেছত মই চেঞ্জ ইন এন্ট্ৰপি কিমান পাই আছোঁ, mc ln of Tf by Ti, and this is what? Always greater than 0, because Tf is always greater than Tf. So your change in entropy is greater than 0. So for irreversible process, your change in entropy will be always greater than 0, and for reversible process, the change in entropy will be 0. So এই চেঞ্জ ইন এন্ট্ৰপিটো তুমি কিন্তু ইয়াৰ লগত কনফিউজ নকৰিবা, ক্লছিয়াছ ইনইকুৱেলিটিৰ লগত কনফিউজ নকৰিবা। ক্লছিয়াছ ইনইকুৱেলিটি ইয়াত তুমি চোৱা, এতিয়া এইটো ইণ্টিগ্ৰেশ্যন লেছ দেন ইকুৱেল টু 0 হৈ আছে। ইট ডাজন্ট মিন দ্যাট চেঞ্জ ইন এন্ট্ৰপি ইজ লেছ দেন ইকুৱেল টু 0। Okay, though it is dq by t is the change in entropy, but this is not the entropy, because you see the integration is what? Closed integral. Okay, it is a closed integral. Closed integral মানে আমি কি কৰি আছো? Again we are coming back. কিন্তু change in entropy মানে কি? আমি coming back নকৰো, আমি কি কৰিম? এটা সেটৰ পৰা আনটো সেটলৈ গৈ। So Clausius যোনটো statement আছে, theorem আছে, it is for closed path. Okay, but change in entropy যেতিয়া আমি উলিয়াম, change in entropy will go from A to B, or from initial state to the final state. Whenever you go from one state to another state, then only you are calculating the change in entropy. But if you are again coming back, then it will be either 0 or less than 0. You understand? So this basically doesn't mean that this is my change in entropy. Change in entropy will be from one state to another state. So this is my change in entropy. This is change in entropy. This to this. Closed integral হলে কিন্তু এটা তোমার change in entropy হয় না থাকে। So these two examples we have seen for a reversible process and irreversible process. We have seen that for reversible process, change in entropy is 0, and for irreversible process, the change in entropy is greater than 0, and which is again given by the second law of thermodynamics. It always holds good. Okay. Now let us calculate the change of entropy in case of a isothermal process. Can you do it? You take a isothermal process. At an isothermal process to be low. You are going from A to B through a isothermal process. And a isothermal process to me change in entropy will have. You have to find out the change in entropy. So তুমি এর পৰা B লৈ গৈছা, taking certain amount of heat dq amount of heat তুমি লৈছা, and your volume is changing from V1 to V2. Volume to তোমার V1 or V2 লৈ change হৈ আছে. So during this process you have to find out the change in entropy. So can you find it out? ds bule go over, I can call it as a ds, change in entropy ds. Here again I have to take the integration. Integration will know. First let me don't take the integration. What I will do, I will write it like this dq by t. A small amount of heat taken from small fraction. এটা গোটেই তুমি এর পৰা বিলুকে তুমি যাব লগা হয়, তুমি কি কৰিব লাগিব? You have to do the integration. If I take a very small portion here, একদম small portion এটা যদি মই লওঁ, ইয়াত মই যদি dq amount of heat লওঁ বুলি কওঁ at temperature T, then my change in entropy from here to here is dq by T. Now change in entropy for A to B, এর পৰা B লৈকে যাওঁতে কিমান change in entropy হ'ব? You have to do the integration. The integration তুমি কিহৰ পৰা কিহলৈ কৰিবা? You have to do the integration now from V1 to V2, because that is changing. আগত মোৰ কি হৈছিল, টেম্পাৰেচাৰ চেঞ্জ হৈ আছিল, গতিকে মই টেম্পাৰেচাৰ কৰিছিলোঁ টি আই টু টি আই, এতিয়া মোৰ ভিটো চেঞ্জ হৈ আছে, গতিকে আই হেভ টু ডু দ্য ইন্টিগ্ৰেশ্যন ফ্ৰম V1 to V2. Proceed করো, now proceed, you find it out, what will be your dq? What will be your dq? This is an isothermal process. This is an isothermal process. PdV, okay, very good. So it will be PdV. Fine. PdV divided by T. Now I will take it over to me. Again you write this P in terms of V. PV equal to nRT, no? So PV equal to nRT. So P will be equal to nRT by V. So P only more killing nRT by V. So ultimately T will cancel out. So what I will have? I will have nR by V dV. nR dV by V. So I will take the integration. I will get ln of V. So ln of V will be equal to nR ln of. So this will give me nR ln of V2 by V1. This is the change in entropy for the isothermal process. While going from A to B, the change in entropy will be equal to nR ln of V2 by V1. So like that I can calculate the entropy. So I can now know how to calculate the change in entropy. But we don't know what is entropy. I mean entropy ki vastu na jano, but one thing we know, I can now calculate the change in entropy. Eta state er upore another state er jete jabo, I can calculate the change in entropy. But I don't know what is the entropy. My A state A thakote kiman entropy ase I cannot calculate. State B kiman ase entropy I cannot calculate. What I can calculate is the change. Here by here kiman change is that I can calculate. So I can calculate the change in entropy. So let me take another example. You know the free expansion of gas. Free expansion of gas. Free expansion of gas. What is free expansion of gas? How to high secondary paisile eta morat nai. Whenever the gas is allowed to expand freely যদি expand করিব দিবা, that is called the free expansion of gas. That means you take a adiabatic cylinder, eta adiabatic cylinder তুমি লোৱা, adiabatic cylinder তুমি লোৱা, and you take some gases here, gas molecules তুমি লোৱা, and imagine that you have a partition here. That means all the gas molecules are like this. এই partitionটা আছে, partitionটো তুমি দিছা দি থৈছা আৰু গ্যাস বিলাক কোনফালে আছে এইটো ফালে আছে. There is no gas here. There is what? Vacuum. This is vacuum. It is vacuum. This is my gas, and you have a partition here. And now you remove the partition. এই partitionটো কি কৰিবা? Remove কৰিবা. So now if you remove the partition, what the gas will do? It will expand. Okay, and hey gas to expand koribo kan tumi kiba externally energy ba force disa niki? No idea. You have given nothing. The gas is expanding on its own. Ta nijor jodi energy asile hey energy pora hi ki hoye ase expand hoye ase. So this is called free expansion of gas. Ei to expand hobo kan tumi bahir pa heat dibo na lage. This is a free expansion of gas. Jodi free expansion of gas hoy, then during a free expansion of gas, how much pressure it is giving here? Kiman pressure di ase? How much pressure it is giving to the vacuum? Kiman pressure di ase? Vacuum ot kiman pressure dibo? Ba kiman force dibo? What will be the force given by the gas to the vacuum? Zero. Vacuum or tumi kiba dibo pariba. There is no opposition. Na? If there is some opposition, then only you are giving force will be meaningful. There is no opposition, vacuum means no, nothing is there. So it will expand freely. So no force is given by the gas. Also there is pressure there. That means what will be the amount of work done? Zero. So in case of free expansion of gas, no work is done. Free expansion ki hoy, work done to zero hoy. So work done zero. Work done to zero. Okay. Work done is zero. Now the question is that I have allowed the gas to expand freely. So it has gone from one initial state to a final state. Initial state to guntu asile. It was the initial state. And what will be the final state? The final state will be this one. The gas will be spread all over the cylinder. What is cylinder? Gas is spread. That is your final state. So this is your final state. Final state. Or it will to my initial state. This is my initial state. Initial state. White is initial, green is final. Is it a reversible process or irreversible process? Is it a reversible process or irreversible process? You are going from an initial state to the final state. Now it is a reversible or irreversible process. Reversible or irreversible? Can I bring the gas back again to the initial state without affecting? Final noise. Noise. কি কারণ মানে যদি মই গেছটো মই এইটো এটা এই পিষ্টনটো সাপোজ যদি পিষ্টন এটা আছে পিষ্টনটো মই একবাৰে ইয়ালৈকে লৈ গ'লো মানে এইটো গুচাই দিলোঁ এতিয়া মই ইয়াতে আকৌ পাৰ্টিশ্যনটো মই আকৌ ইয়াত দি পেলাই যদি পাৰ্টিশ্যনতে ঠেলি দিওঁ তেতিয়াহ'লে কি হ'ব আকৌ আগৰ জেগালৈকে আহিব নাই without affecting the surrounding? Yes or no? Exactly. So মই কি কৰিব পাৰোঁ চোৱা এই যেতিয়া মই ইয়াতে পিষ্টনখন এই পাৰ্টিশ্যনটো মই যদি ইয়াত দি দিওঁ এইটো এণ্ডত দি পেলাই পাৰ্টিশ্যনটো এনেকুৱাকৈ ইয়ালৈকে মুভ কৰি দিওঁ so it is not affecting the surrounding, it is coming back to the initial state. Into what I am doing certain amount of work to push this gas from here to here. So without doing any external work, the gas will not automatically come to the initial state. তুমি হাজাৰটা অৰ্ডাৰ দি থাকা ৰিকুৱেষ্ট কৰি থাকা the gas will not come. যদি গেছটো নিজে নিজে নাহে then this is an irreversible process. Okay, আৰু এইটোত আমি যদি চেঞ্জ ইন এন্ট্ৰপিটো উলিয়াওঁ the change in entropy here in this case will be always greater than 0. আৰু সেইটো চেঞ্জ ইন এন্ট্ৰপি উলিয়াবৰ কাৰণে আমি কোনটো ফৰ্মুলা ইউজ কৰিম? We will use this formula because here your volume is changing from V1 to V2. Volume is changing from V1 to V2. So yet more into change in entropy formula আহিব. The change in entropy formula will be del S will be equal to NR ln of V2 by. So this is the expression for change in entropy in case of free expansion of gas. পরীক্ষাত কেতিয়াবা এটো ফুটে. Find out the expression for entropy change in case of a free expansion of gas, and it is an irreversible process, and this will be always greater than 0. Here to be shown the system, the entropy change of the system is nothing but the entropy change of the universe, because it is an isolated system. Isolated system means the surrounding of the touch নাই, because surrounding of কি 0 হৈ যাব. So only system যেটো হ'ব that will be the universe. So for the universe it will be greater than 0. So it is an irreversible process, so there will be greater than 0. Okay, so let us stop it here today.